Today's notes starts the next unit. This will not be on tomorrow's quiz, nor will it be on next week's test. This is the starting of the next unit. Yes,
I thought you said yesterday's notes weren't going to be on tomorrow's quiz.
that's true, but yesterday's notes will be on next week's test.
Oh, okay.
Okay? So this is just the beginning of the new unit. It's just an introduction and a fair number of new terms for you. Some that are old, but several new terms that you must know or this unit will just destroy you. Okay? So we start with some old familiar things. Parallel lines. We've talked about this before. Parallel lines are coplanar lines that don't intersect. They have to be on the same plane, even if that plane's not drawn. It can, be a diagonal plane or whatever. On the diagram, they're marked either with an arrow or with a triangle in the middle. Your book tends to mark them like, you don't need to write this, they tend to mark them like this. That's just not my preference. It doesn't really matter. I usually close them up and color them in. But it doesn't really matter. It's the same thing. One thing to be careful of is that in this diagram, it looks like DH and CF are parallel, right? We cannot assume that they are parallel, right? I don't know for sure. They could be off slightly. So sometimes the question will say which ones appear to be parallel. Sometimes they'll ask which ones do we know are parallel. Now, can you assume then that two lines aren't parallel? Well, for example, CF and HF, I know they're not parallel because they intersect. Okay? Or if I did AD and GE, those aren't parallel because they're not in the same plane. Okay? All right, so the symbol for parallel lines and geometry symbols almost always make perfect sense. For example, this is the symbol for parallel. Well, what looks like is true about those two little marks?
That they never intersect.
So
They're parallel.
it looks like they're parallel, right? The symbol looks like what it is. That, and if you're thinking about language, it looks like two L's, like the middle of the word parallel. It's genius, I tell you, genius. So, which lines in this diagram are known to be parallel? Well, for example, we know that segment AB is parallel to segment CD. What other two are known to be parallel? Yeah.
Segment GH and segment EF.
Yes. We know that those are parallel. Perpendicular lines are lines that intersect at right angles. So the way that we mark that on the diagram is with a square at their intersection. Just like with parallel lines, just because two lines look perpendicular, we can't just assume that they are. You either have to be told that they are or have enough information to conclude that they are. The symbol for perpendicular, well, looks perpendicular. Again, good idea. Occasionally someone says, well, why didn't they make this the symbol for perpendicular? At which point I roll my eyes and go, what could possibly go wrong with that? Looks like a plus sign. Okay, so, plus sign was already taken, so they went, okay, we'll leave it at that. So, which lines are known to be parallel? We know, for example, that segment AD is perpendicular, sorry I said parallel just a second ago, to segment CD. Where they intersect, they make a right angle. There's another pair that's given here. Which ones are parallel? Someone who hasn't volunteered. Yes, Christina.
Segment GH and segment DH.
Yes. Segment GH is perpendicular to segment DH. Where they intersect at H, they make a right angle. So that's all for old stuff, and that's just getting everybody kind of on the same page. Now for new stuff. A transversal is a line that intersects two coplanar lines in distinct points. When it says distinct, what that means is different. Some older math textbooks say two unique points. Right? They're not the same point. By the way, let's learn a little bit about English while we're in here. So anytime you see the prefix trans, do you know what that means?
Like transform.
Transform has that, but what does the trans part mean? Not necessarily.
Transfer.
Okay, you're giving me examples. Transfer, transportation.
Moves. Opposite.
They're all good guesses. It literally means cross.
Oh.
So, if you think about American history for just a second, I'll give you two examples from history. I'm doing all kinds of cross-class stuff today. So, after the Civil War, they built the railroad that went from the Atlantic Ocean to the Pacific Ocean. It was called the Trans something.
Trans-Pacific.
No, it didn't cross the Pacific.
Atlantic.
What?
Atlantic. Transatlantic.
It didn't cross the Atlantic either.
No, transatlantic slave trade. That's what we're thinking of.
Right, because that was across the Atlantic.
Um,
That's what the
Where was this?
Transportation.
United States.
States.
Roads.
Wow, I'm gonna have a talk with your social studies teachers. The Transcontinental Railroad,
Oh, I remember that now.
right?
Don't tell me story.
It crossed the continent of North America from east to west. Okay, I'll give you another example. Maybe you'll get this one right. So there was, during the time of telegraph still, there was a cable that was put down from, I think it started in New York and then ended like in England someplace.
Transatlantic.
It was the transatlantic cable. Right? And later on, there was a phone cable that did the same thing. This is in the days prior to satellites and internet and all that kind of good stuff. Okay? But anything that has trans in front of it means cross, like transport. Right? It literally means to cross from one port to another port. Okay? So any word that starts with trans means to cross from one thing to another thing. So, enough on that. A transversal is this line that crosses from one line to another line. So here, C is the transversal crossing lines A and B. Notice when I do that, there's 4 angles formed up here and 4 angles formed down here. That's always going to happen when you have 2 lines crossed by a transversal. There's always going to be 8 angles, every single time. Okay, now, certain pairs of those angles, on to page 2, have names. And I'm not talking, Bob and Susan. Man, this is a tough room. So, corresponding angles are in the same position relative to the lines in the transversal. For example, if you look at this group of 4 angles, angle 1 is above the transversal and to the left of its line. Now look at this group of 4. What angle is above the transversal and to the left of its line?
5.
Angle 5. See how that angle 1 is above the transversal to the left of its line? Angle 5 is above the transversal and to the left of its line. That's an example of what are called corresponding angles. Again, when things correspond, that means they match or they go together in some way. So let's list all the pairs of corresponding angles in the diagram. So angle 1 and angle 5
Wait, what did you say correspond means?
match. So like, for your hands, your left thumb and your right thumb basically match. They're the corresponding parts. All right, what other angles correspond to one another in this diagram? There are several examples.
2 and 7.
Yep, angle 2 and angle 7, very good. 3 and 6, yep. 4 and 8.
Wait, how is 2 and 7?
2 is in the top right, 7's in the top right. They're both above the transversal, and they're both to the right of their respective line.
Okay.
So they're in the matching location. So those are corresponding angles. The other ones we're going to look at, the name tells you what you need to know. So alternate interior angles are non-adjacent angles that are between the two lines. The part about between the two lines, that's what makes them interior. But on opposite sides of the transversal, another word for opposite is to alternate. No, 2 and 5 are on the same side of the transversal. They're both above that line that joins them.
3 and 6. 3 and 5. 3 and 8.
Wait, they need to be between these two lines. That makes them 2 and 6. There we go.
Okay, so it's crossing the transversal and
Right, they
opposite.
alternate sides of the transversal. One's on one side, one's on the other side.
That makes sense.
And then what?
4 and 5.
4 and 5, yes.
Oh,
And then just like alternate interior angles, we also have alternate exterior angles.
Oh.
Bless you. So what kind of angles would be alternate exterior? Not in between the two lines, outside the two lines. Yes, ma'am.
8 and 5?
5 is in between these two lines. Wait, hang on. And 5 and 8, go ahead.
1 and 8.
1 and 8, there you go. Angle 1 and angle 8. Yes, Addie?
7 and 3.
Okay. Angle 7 and angle 3. Those are alternate exterior angles. And the last type that your book does are same side interior angles. Instead of alternating sides of the transversal, they're on the same side of the transversal. Yes.
2 and 5.
Yes, angle 2 and angle 5. There's another pair. Yeah.
4 and 6.
Yeah, angle 4 and angle 6. Now at this point, if you were real observant, you might go, well, there are alternate interior and alternate exterior, and then there are same side interior. Why aren't there same side exterior? Well, there are. Your book just doesn't talk about them. You're welcome to use them. They work the same way that same side interior angles work. So like, for example, angle 1 and angle 7 would be same side exteriors. And 3 and 8 would be same side exteriors. Okay, so let's practice a little bit with this. Use the diagram at right to name all pairs of angles of the given type. So we'll start with alternate exterior angles. So in this diagram, here's our transversal. We want alternate exterior angles. We want them to be outside of the two lines, and we want them to alternate sides of the transversal from one side to the other. Yes?
1 and 6.
Yep. Angle 1 and angle 6. There's another pair. Yes, sir.
Angle 2 and angle 7.
Yes, angle 2 and angle 7. Those are alternate exterior angles. All right, let's do corresponding angles. Remember, corresponding angles are angles that are in the same location. Yes, Addie.
2 and 8.
2 and 8? Absolutely. Yes, Abby.
1 and 5.
Yep. Angle 1 and angle 5. Christina?
3 and 6.
Yep. Angle 3 and angle 6. Grace? Oh, I thought you were raising your hand. Yeah.
4 and 7.
Angle 4 and angle 7. You may have noticed that there's more corresponding angles when you have a diagram like this than there are of anything else. All right, let's do same side interior angles. Grace.
4 and 5.
Very good. Angle 4 and angle 5. Abby?
3 and 8.
Yes. And then last but not least, alternate interior angles, which actually when we get down to doing problems beyond this unit, we see alternate interior angles probably more than anything else. Yes, ma'am.
3 and 5.
Yes, angle 3 and angle 5. Yes, Grace.
4 and 8.
Yep, angle 4 and angle 8. All right, so let's go to a slightly more complicated diagram. So it says for each angle pair, first identify the transversal. Then classify the angles as to what type of angles they are. So let me show you on the first one. If I'm talking about angle 1 and angle 3, what's the line that crosses from angle 1 to angle 3? M. That's the transversal. Remember, transversal means to cross from one thing to another. So when I'm looking at those, I don't need to look at anything down here. Now, you can't do that easily, but sometimes I have people who will actually put their hand over it. I'm just looking at this part up here. So, what type of angles are angle 1 and angle 3? Yes.
Corresponding angle.
Yeah, these are corresponding angles, and we're going to abbreviate because it's just too long otherwise. And I also use the angle symbol and an S to make it plural, so corresponding angles. That's why there's an S at the end of that.
Wow, mathematicians really are lazy.
Yes, we are. I mean, we're efficient. That's what we are. All right, let me get rid of that. All right, angle 6 and angle 2. So, transversal for that. Yes, sir. N is the transversal. So, I don't need to be looking at anything up here. I'm just looking down here. So, type of angles. Yes, Grace.
Alternate interior angles?
Perfect. Alternate interior angles. Because they're in between line M and P, and they alternate sides of the transversal. Perfect. All right, let's see. 1 and 4. Addie, what do you think the transversal is?
M.
M, that's exactly right. And Lexi, what kind of angles do you think those are?
Alternate exterior angles?
Yep, those are alternate exterior angles. All right, 3 and 5. What is the transversal? Anyone? P. And what type of angles are those? Same side interior angles.
Can you do S-S?
I guess that's okay. My usual cutoff is anything that's longer than 4 letters, I'm happy to abbreviate it. Anything shorter than, 4 or less. 4 is kind of on that borderline.
Yeah, like June and July.
Yeah. You feel silly abbreviating them, right? Because it's only one more letter. All right. Go ahead and do the last 4 on your own, and then check with the people around you and see if they agree with you. If not, discuss. If a discussion doesn't work, arm wrestle. So, discuss. So y'all are in complete agreement?
It's not coming. Okay, it's kind of making me feel rash.
Do you just not want to be here today? Wait a couple minutes. We're almost done.
Besides, we only have 4 minutes left in class.
All right. So let's see how you did. For 4 and 6, transversal is P, and those are alternate exterior angles. For 6 and 1, the transversal is N, and those are same side interior angles. One and 5, the transversal is again N, and those are alternate interior angles. And then 6 and 3, transversal is P, and those are corresponding angles. Any questions about that? All right, your assignment tonight is in the book and also to study for tomorrow's quiz.